Okay, now that we've moved on from planetary weather, let's look at our weather, mid-latitudes, where we live. Uh, so I thought I would just start talking about what we see today. What we have on this map here is a surface map. You've all seen them, probably more than you want to now. So have high pressure, weak but high. Cold front separating it from warmer weather. Pretty large high pressure, as we've learned, off the Bermudas and all across the southern part of the United States right now. If you were to look further up in this map, you'd see big high pressure over parts of Canada as well right now. And then further north, more low pressure. All right. So what does that mean for the mid-latitude? Well, there are air masses. We've talked about air masses at the beginning of the course, and if you're like most of my students, you don't remember much about them. So let's refresh on that a little bit. Air masses are large areas covering very similar types of air. They form where the air typically doesn't move much. They take on the characteristics of what the ground is like underneath them. So if I have a large high pressure out over the southeastern Atlantic, what do I have? Well, I have a very uniform temperature. Temperature probably in the 70s or low 80s. What else do I have? A lot of water, right? So a lot of moisture in that air. I have a maritime tropical air mass. Let's do the other extreme. Let's go into Canada. If I go into central Canada, what do I have? Well, during the summertime, a lot of just plain old tundra, or relatively, there's one characteristic. Other one is it doesn't get as much sunshine, right? It's further south. So it's going to be a little bit colder, right? And in the wintertime, you're going to have snow on the ground. So it's going to be much colder. So there is your continental polar air mass, Air masses can form over northern waters as well. Let's take the North Pacific. If I have a big high pressure sitting out there for long enough, air is not moving a lot. What's it become? Well, it becomes cold and damp. What happens in the west coast of the United States a lot? They're cool and damp. So that is a maritime polar air mass. Continental tropical air mass would be like the desert Southwest. Very dry, very hot. So all these air masses come across the United States at some point. What divides the air mass is a front. So if I'm bringing in, and the definition of the front very much is what the front is bringing to your house. So if I have a cold front west of my house at one time, or to the south, north of it, like I do today, if you're in South Dakota, I have a cold front here. Look in Kansas. I don't have a cold front there. I'm in warm air. So I have probably maritime tropical to continental tropical air right there. North of it, I have continental polar air. So right across that boundary is a front, and the cold front. Now, if it's moving south, which this says it is, somewhere in Nebraska and all are going to switch over to that continental polar air mass. So they're going to change air mass. When they change air mass, they're going to change characteristics of the air. The air will be cooler and it'll become drier. Now, if it goes back north, like this warm front here, what's happening is you're switching from that continental polar air to more maritime tropical air. You're getting warmer and more moist. So as these fronts cross your area, that's what's happening. That's what's bringing the change in the weather to your house. You're changing air mass. Now that we've changed air mass, let's talk about these lows. Not a lot of lows on the pressure right now, but there is one right here over Minnesota. Along a frontal boundary, extratropical lows form. There are a lot of extratropical lows that form every year. You think about it, we have hurricanes that form, maybe we get 20, 25, even 28 or so in a major year. Extratropical lows are constantly moving across the United States. We may have 2 or 3 moving across in a day. So what do you get? maybe several hundred of them moving through during the year. So extratropical lows are very frequent, and they're always accompanied on a front with a temperature change. That's the main difference from tropical. There's always a temperature change there. So in this case, temperatures go from the 60s on one side of it to the 80s on the other. 20-degree temperature change. Dew points from the 60s or even low upper 50s into the mid 70s on the east side of it. That's a significant temperature change, dew point change, moisture change. So we have those two characteristics coming together. And we know along a low pressure system, winds flow counterclockwise. Well, guess what? If you're on the west side of it, that's going to be pushing the cold air south. If you're on the east side of it, that's going to be pushing the warm, moist air north. So the more powerful they are, the more powerful the push. And they're going to get more powerful when there's more temperature contrast. The weaker the temperature contrast, like in the summertime, the weaker the lows are. In the wintertime, they're much stronger. So now that we've dealt with the basic weather features that we got here, let's take a look out into the future just a little bit here. Let's see what's going on. I noticed this across parts of Ohio, into the parts of West Virginia and stuff, and Indiana, Illinois. On Tuesday, there's a slight risk of excessive rainfall. So, okay. We just looked at today's surface weather map. What did you see? A little low up over maybe Minnesota, a little cold front there ahead of it. Nothing really significant that I would talk about, thinking about it on a large scale, right? But this is all a model forecast based on one model. There's a lot of models, and this is not by any means the highest resolution model. But I wanted to look at a couple things here. All right. Well, I've talked about jet streaks. Well, we have a jet streak here. Strongest winds right over the Great Lakes. This is tomorrow evening. So with that, divergence, left front, right rear. Well, right here is divergence. So what do I wind up with? I have a lot of wind divergence in here. And if I'm looking at this right, what I've noticed too is winds pick up to 50, 75 knots in here, and down below it's only 45 knots. Well, guess what? The southern parts down here in Ohio and all are going to get pretty doggone good wind divergence, right? So the air is going to be pulling apart. At this level is 200 millibars. Well, that's about 30-some thousand feet. So I've got very strong divergence there. That divergence means that the air down by the ground is going to want to lift. Okay, so what's happening with that? What's happening is the front that you saw back here has pushed down a little bit closer. Yeah, it's weak low pressure here. It's not very strong. But that front's pretty, 1021 high, pushing down. The front actually runs about right like that, probably. So that front is providing a lifting mechanism. Cold air pushing in. It's steeper, pushing the air up. So it's producing showers and thunderstorms in this area. Well, guess what? The other picture just showed that we have strong divergence aloft. Convergence then would be at the surface, so the air is rising. So we're pushing up a lot of air. Oh, and with that, how much moisture is in the air? Well, this is precipitable water. In the wintertime, if you get a quarter to a half-inch precipitable water over your area, you're doing pretty good. You have pretty high significant precipitable water. In the summertime, it goes up, usually to an inch or so. However, when you get above 2 inches, that is excessive. Guess what? All that moisture coming up out of the Gulf of Mexico here, from the Atlantic, the tropics, all up into here, is being concentrated right along that front. We had good moist advection. So you're getting over 2-inch precipitable water. So now I've combined plenty of moisture. I've combined very strong lift. I probably have pretty good instability with some of that. What's that going to produce? A lot of very heavy raining thunderstorms and showers. That is why you see that area being outlooked. So what has that done with mid-latitude weather? We've got contrasting air masses. We've got a weak low pressure system, extratropical. We have a jet stream going by. Well, you just combined almost all what you're going to talk about here in just a minute. So I'm going to go flying through the PowerPoint here pretty much because we've just talked about it. But I want to show you a couple things in it. So we talked about the air masses. One of the interesting things about air masses, think about it. In the wintertime, there is a lot of cold air up in Canada. When it moves away from that snowpack into some parts of the United States where the snow is not there, the air is going to modify very quickly. On the other hand, maritime tropical air is moving in, and it's pretty warmed up and moist, cloud cover and all that. So it doesn't tend to change as quickly. So the continental polar air masses are going to change much quicker than the maritime tropical or maritime polar air masses. We talked about fronts, how they lift the air up. Warm air, always lighter than cold air. So tending on a stationary front, the warm air is going to tend to rise over it. And in this warm advancing. Cold front means cold air is advancing. Stationary front means neither one is moving. And think about a cold front, very steep because the air is very, very dense compared to the air ahead of it, pushes it up more. Cold fronts can come in all different directions. I live on the east coast of the United States, east of the Appalachian Mountains. We get something called a backdoor cold front. I hate them. I like sunshine. Backdoor cold fronts come down out of the northeast. High pressure becomes centered up over eastern Canada, maybe even northern Maine. Winds. Where's northeast winds coming from? For my house? Off the North Atlantic. What's the North Atlantic have? Cold temperatures, lots of moisture. So I wind up with cloudy skies, maybe drizzle, and cool. And when we get these into spring, when I like to have sunshine and warm weather, I'm not getting it. So, occluded fronts. Near the life cycle of a extratropical storm, eventually the cold front typically moves faster than the warm front. So you have this warm front out ahead of it, and a cold air mass trying to catch it. As the storm is intensifying and reaching its final phase of intensification, that cold air reaches the warm front. What happens is that cold air pushes that warm air up so that you actually wind up with a warmer layer of air aloft. That is an occluded front. Doesn't happen until the end of the cycle. Now, Norwegian cyclone model. What it says is everything we talked about. We have the divergence aloft, which start with a low, weak low, between a warm and cold front right there. As it intensifies, it pushes down more and more. The cold air goes further south, warm air comes further north, gets more intense. And you'll notice as we get to the end, we begin to get that occlusion. And finally, it gets a very strong occlusion. All that warm air has been pushed aloft. There's warm air here, but it's all up in the upper atmosphere now. And you can see these very typically on satellite, watching them grow and decay. Notice this comma head shape to them as they develop. Very classic on satellite. And we get dry air pulling in from the west as the low gets stronger and stronger. So it begins to dry out. Remember, you've got cold, dry air coming in. And it's sinking on the western, coming into the backside there. So it's getting drier and drier. Wind up ending that precipitation, maybe pretty quickly sometimes. All right. Dr. Toby Carlson at Penn State developed what he called the conveyor belt model. It can be confusing, but it really explains why we get a comma head shape. So I have a cold conveyor coming in off the ocean. It's moist. It's rising up over this low. As it rises up, eventually it gets hit by the westerlies and turns back to the east. This creates that comma head. So that cold conveyor of cold, moist air moves westward, lifts, creates a comma shape to that cloud mass. Many times you get some of the best snowfall under that comma head. Depending on what sector of these extratropical cyclones you're in as to what kind of weather you get. If that extratropical cyclone goes over Chicago and you're living in Ohio, you're going to be in the warm sector. You may get a little bit of ice and snow at the very outset. Warm front's going to go by you. You're going to wind up with rain, maybe even get some severe weather along the cold front. Now, same low. Instead of tracking over Chicago, let's put it over Pittsburgh. Well, now all of a sudden I'm on the west side all the time, right? So I've got all the cold air coming in, still being pulled in. So all that precip is probably falling as snowfall, and it's staying cold and windy. You have different patterns to extratropical cyclones. The one that is the worst, probably for your area, had the most potential would be the Colorado. Develops over the Rocky Mountains and moves to east across your Ohio. It's going to bring a lot of moisture up from the Gulf of Mexico. The Alberta Clipper, more of a zonal flow pattern, and look how far away it's way up north. Doesn't have access to a lot of moisture. The other thing is, remember, these are extratropical, called cold core for a reason, because the temperature actually drops faster and faster the further up in the atmosphere you go in the troposphere. So that means the pressure is going to dip further and further down. The line's 300 millibar goes lower and lower. That's a cold core cyclone. And yeah, some of them are non-occluded, but they're still there. They're still cold core. Warm core. I talked about it with the Southwest United States monsoon. It gets very, very hot at the surface, creates low pressure at the surface, but it's hot. So the air pressure density is very minimal. So what you wind up with across it then is more of a slower pressure drop. You wind up with it becoming warmer and warmer aloft. So we have the different types of high pressure systems. I think that's about what I wanted to cover here. So I hope you got something out of that. Let me know if you have any more questions.